Good day to everyone. I am Vijay from IDEC Controls India Private Limited. In this video, we are going to look into SE2L's connectivity with ROS, that is Robot Operating System. Firstly, we'll look into the introduction to ROS, that is knowing the history about ROS and few components which make up ROS. Then we will move on to the actual crux, that is communication with and configuration of SE2L with ROS. Moving on to the introduction to ROS. ROS was originally developed by Stanford Artificial Intelligence Laboratory in 2007. Later on in 2008, the development continued by Willow Garage, and from year 2013, ROS development and maintenance are being done by Open Source Robotics, which later changed its name to Open Robotics. The two current running ROS, that is Robot Operating System, are Melodic Morania and Neotic Ninjamis. The first one will support till 2023. The support is extended till 23, and the second support is extended till 2025. Well, Robot Operating System is an open source which can take libraries or APIs with ease, and also ROS acts as a middleware between uh, user, that means us, and the OS installed in the PC or the machine interface, which is available. It actually helps in communication with the actual hardware. So let's say if you're having SE2L and we as a user would like to communicate with the hardware and would like to take the data. So and the interface which you're using is the PC or the other hardware, just like Raspberry Pi or the other interfacing devices. So in that case, we need to again install the middleware, that is ROS, to communicate with the hardware, the actual hardware. In our case, it is SE2L. Whereas, let us see what an meta operating system means. It is actually built on top of operating system and allows different processes, those are nodes, which we'll see little later, to communicate with each other at runtime. Majorly, ROS runs on Linux operating systems such as Ubuntu and Mint. ROS is built up with set of software libraries and tools which help us to build our dedicated applications with ease. Since it's an open source, libraries gets updated and more libraries are integrated. Right? Then ROS is made up of plumbing, tools, capabilities, ecosystem. So this is how we have to sum up to make a ROS. So let's go through each part. The plumbing can be also called communication middleware, which helps two or more programs to communicate with each other. The communication middleware provides APIs to us to send and receive various types of data between multiple programs running on a computer or an interface. In short, the plumbing part in ROS creates a network of programs or nodes which are communicating with each other by sending or receiving different kinds of data in terms of topics. So these terms such as topics, nodes, publisher, subscriber, we'll see a little later in the architecture part. So moving on to tools, the tools represent or the tools present in the ROS helps us to debug and monitor various kinds of data that are sending and receiving by ROS nodes, which you have seen previously. So there are graphical tools and command line tools present in ROS, which are built in ROS. So one of the tool which you are going to look into in this video solution is RWITS, which you are seeing on the left side. Using the plumbing feature in ROS, many robot software blocks are built for doing various capabilities such as state-of-the-art algorithms. Also, ROS has many communities where rapid development is being done. There are more than 2000 plus libraries or APIs to which ROS supports. Also, the three official languages to integrate ROS are Python, CPP, and Lisp. There are others as well, but not officially proven, such as C Sharp, Ruby, Java, etc. There are many other languages. There is a vibrant community of developers and users around the globe that makes ROS as a unique framework in robotics. ROS is one of the software frameworks used in most of the universities for robot research. Other, uh, other than academic research, ROS is also used in robotic companies to prototype their softwares. Right. So this is why it is called as ecosystem. Now to understand the architecture of ROS consists of a master node and other interfacing nodes. Each and every node which requires to send or receive data needs to be registered with master node. All the data or messages are stored in ROS in master node since the other nodes have registered to it. That means uh, once a node has been established, it has to register with master. As we have seen previously, plumbing takes place in ROS as an initial step of communication. So that is node can publish, that is sending data, and subscribe is receiving of data. So each node communicates on a topic. Let's say today we are discussing on the topic of ROS. So we will learn in and out of that specific topic only. Similarly, we may have various topics in communication. Let us know the understanding of the terminologies. Later on, we can move on to the practicality of understanding what a topic means. So, firstly, node. It is called as an instance which is created as soon as we register it to the master. Per se, master is also a node. Usually, sensors, motors, robots are considered as nodes. Master, we can say this is a node which handles registration of other nodes and stores the data. Topic, the name itself suggests that data transmission between each node happens on a topic. It is a form of asynchronous data exchange which where multiple nodes can send or receive data. Message, this is the actual data which we are transmitting in our case of SE2L, distance measurement data. Service, it is a form of data which is being exchanged between two nodes only. So it is also called as synchronous communication since it is one-to-one. Since there are many libraries integrated in ROS, it has wide variety of applications. As you can see in this slide, we have drones, humanoids, surface robots, manipulators, or in other words, industrial robots, marine and motors, sensors such as laser scanner and other components such as Raspberry Pi or Arduino. Well, let us now move into the configuration of SE2L with ROS. So for the configuration and the communication, initially we'll be having, as I said you previously, that we have SE2L as a device, that is as a node, and it is being communicated with the help of Ethernet with any interfacing device such as PC or maybe Arduino or some other instruments where it acts as interface. Then on top of that, usually we should be having a Linux based install, because ROS by default it supports Linux as a default medium. Then with that we need to install ROS in the Linux. So with the help of a few of the libraries or a few of the websites, a few websites I will be showing to you. So for this requirement, in this video, I have used a PC based Linux system of 2.04 focal version and SE2L with Ethernet cable and an internet connection to install ROS and its libraries such as URG node. So it is not compulsory that internet connection should be available with you people if ROS has been installed. Once it is installed and libraries are installed, internet is not required. But initially it is required for installation of ROS and the necessary nodes. So we'll initially start with this step of installation of ROS. So before that, in this schema, I mean, as I'm integrating SE2L with Linux, so my SE2L's IP address is 192.168.1.10, whereas for my PC, I've set it as 192.168.1.20. So you can set it as per the requirement, as per the machine's demand. So for in my case, I am setting these two IP addresses. So moving on to the installation of ROS. So I'm using Neotic Ninjamis Ninjams as a reference here. Um, Actually, it supports till May 2025, and it was launched in the last year, May 2020. So that's why I'm taking this specific ROS. So for installation of ROS, we can follow the following. There are few steps which has to be followed from the website which I'm showing to you in front of. It is in front of you. So basically, for this, it requires 1.5 hours of time for installation. For that, in during that time, we should make sure that PC is not shut down, or maybe due to some other reason, it should not turn off in between. Then for ROS functionality, basically we require 4 GB RAM to process it fast enough for the fast processing, and the PC requirement, the memory should be of 20 GB because the installation takes a little bit higher GB. And if there are any other installations along with that, so that's why I made it as maximum as possible to 20 GB. Here, the same procedure which are given in the website over here, I have just categorized them into flowchart format. For that, we have to open a new terminal in the Linux system. So once the new terminal has been opened, we just need to follow the step-by-step procedure in the commands which are provided here. So yeah, the flowchart is quite easy to understand. We just need to process one step after the other. If there is any yes or no questions being asked in between, just press S because it is asking for our permission to install that specific library or the API. And after installation of all the ROS necessary libraries, so lastly we have to install Python, because the programming, the execution, or the values which are taking from the ROS with the help of ROS from SE2L is with the help of Python. So that's why I'm installing Python also. So once the ROS has been installed and the Python library has been installed, we will move on to the next step, that is we have to install the node of SE2L, which is called as URG node. So for this installation, we just need to execute a small command in the same terminal which we have opened, that is the command which we have to go with is sudo apt-get install ROS neotic urg node. So this one over here is the node, the library or the API which we have to install specifically for the SE2L. Right. So once it is installed, to check whether it is communicating with SE2L, we just need to execute this command, the ROS run urg node IP address, the IP address of the SE2L. So previously in few slides back, I have mentioned that the IP address which I've set for SE2L is 1.10. So once I just try and it is something like pinging operation, but here in this case we are actually trying to open the port. Uh, so once I execute this command, I'll get the result in such a way that I'll get the unique ID of that specific SE2L, and it will say that it is streaming data. That means port has been opened and it is sending the data. So in the next step, after installation of URG node, we'll process through the Python code. So before that, we'll see few more commands which might be useful before using the Python code. So initially, for executing of the Python code, we have to open 4 different terminals. I'll tell you why. First thing is to run the ROS, we have to open the ROS system. That means just like turning on the PC, that means Windows is getting on or Linux is getting on. So for that, ROS has to be run on the machine. So for that, there's a specific command called as ROS core. So once we execute this, ROS is started and it is ready to implement its operation. So in terminal number 1, I just execute ROS code, and I'll be taking one more terminal to open the port of URG node. So the same command which I've seen previously while testing of ROS URG node. So for that, ROS run URG node IP address and the IP address of the SE2L. Once we have done that, it will show as successful. It is connected to a specific node within a unique ID, and streaming of data has been done is being doing. In some cases, what happens in the process of installation of RAW, someone might miss a certain step of bash, so it might not be communicating. Even the ROR core cannot be communicating. So in that case, we need to execute this command called as source with a path which is being provided here, right? So for every terminal, whenever we are opening every new terminal, we have to execute this command in case if it is not communicating or if it is not giving proper results, right? Then the third terminal, this is for the visualization. I mean, in ROS construction, we have seen that there's one contribution for visualization as well. So wherein we can try and monitor or diagnose the problems. So for that, ROS RVs is the tool which is built in ROS once again. So we just need to execute ROS run RVs to open the visualization. So once the visualization screen is opened in a different window, we need to add the laser scan, because the laser scanner, the results which we need to showcase or to see, for that we need to add an additional tool. So just click on add, click on the just select the laser scan and click on OK. Once we have done that, it will come over in the pane over here, and after that, in the global options fixed frame, we need to type in laser, and in laser scan topics we have to mention scan. So from where we actually get the values. So on the right side, you can see the laser scanner readings or the physical view of the outline, right? So to if you are having some trouble with the visualization, maybe you can try and change the sizes or the style of which it is trying to show. Okay. Then finally, in the last tab is the executable tab, wherein we can get the values. So here, before proceeding to the Python code, uh, I'm trying to check the list of topics which we have. So the executable command is ROS topic and the list of topics which we have. So ROS topic list. So once we do that, we'll get the list of topics which are available, which are currently available in the ROS to communicate with. So as you can see, we have URG node. In that we have parameter description or parameter updates, which we can try and do it later. if required. And scan is basically get the values of the laser scan. So this is one of the topic which we'll be communicating little later. Then the second command might be useful is ROS topic echo scan hyphen n1. So in the ROS topic, we are selecting the topics scan, and to get the result we have to enter echo. So these are actually syntax for in Linux to execute the ROS commands. And hyphen n1, I'm using it for to get only one reading. That means only one feedback, or the receiving of values. If I'm not using a hyphen n1, that means these datas will be continuously received from the SE2L. So I just want to get only one format of data. Suppose if I'm sending, if I would like to receive only one range of values, so I'll just write minus n1, that means hyphen n1. Okay, so here you can see we have header, angle, minimum, angle, maximum. So there are few values which are received. Apart from that, we have received ranges and intensities as well. So ranges means the actual distance values. So these are actually are in the multiples of 1000. So we'll see in this step over here. So this is how the outline of SE2L looks like. So this direction over here is 0 degrees, and if it goes from 0 to all the way to 270 degrees, whereas the values which we get from SE2L with the help of ROS is 1080, 1081 points together altogether. So if you're considering 0, we have to consider 1080. So for every 1 degree I am getting 4 points. So let us just convert it into other format, that is for every 0.52 degrees I'm getting 1 point. That means the readings which are shown over here in the ranges that are in the format of array. So this one is 0.25 degree. The value which is shown over here is in terms of that has a multiplication factor, and it is of 25 degrees. So this is like next one is 0.25 degree, next 0.75 degree, um, 0.5 degree, 0.75, and this is 1 degree. So in the similar way, we just need to recalculate or resolute ourselves to the points which we are getting from the SE2L. Then moving on, there is one more nice command to get the information of the publisher and subscribers which are available with the ROS. If you are trying to uh, get the information from the ROS scan a specific topic, so how many publishers are available and how many subscribers are available with respect to that specific topic, that information also we can receive. So for that, ROS topic info and the topic name, this is the command. Then to check the data types which you have seen here in this step, like header, angle max, angle min and max, increment, in the same way ranges or intensities. So for all these data types, we can just go and execute this specific command, ROS MSG show and sensor messages laser scan. So this is the library wherein we have to check. So once we execute that, we'll get the data types. So you can see here for ranges, it is float 32. Square brackets are available. That means these are in the format of array. Okay, so once we get this information, maybe we can play around to get the data in a appropriate way. So if say I'm taking a value from here and I do not know exactly what kind of data type I'm dealing with, then this is where we actually get the proper information from. Then to execute the Python code, we need to type in Python 3 as executable command, then the file name, that is rosscan.py, which I have done the programming, and I've named the file as rosscan.py as an extension. So here just explain you a brief of the Python code which I have done. I have imported the libraries of ROSPy and LaserScan. Then I have created a function wherein I'm taking the values that are ranges, right? We have seen here earlier. In the ranges, the first is 0.25 degree, then this is what we say, zero point 0.5 degree, 0.75, and uh, 1 degree. So let's say 0.25 means 0 to 0.25, that is a value which you are getting here. So that's why I have taken the range value as 0 for the 0th degree. For the 5th degree, I'm taking the range value as 20. So it goes on, and I'm multiplying it with 1000 because the factor which we need to multiply, as I said you previously, was 1000. So that's why I'm multiplying with 1000 and rounding off to 2 decimals only. And the reading which I'm getting is in terms of mm. Okay, that's why I'm printing the values which I'm receiving in the range of a certain index, multiplying with 1000 with a rounding off to 2, and I'm showing it as mm. Then I have taken few readings over here, then initializing of the topic, and there is a specific library function which I need to target, that is subscriber. In that there are few attributes which we need to fill, that is topic, then the laser scan, the library, and the callback function which we have mentioned here. And finally, once we execute spin actually means the function spin actually means the command is being executed repeatedly until unless we end the Python code. Then here we are receiving the continuous command. So this is how we get the values, I mean the result once you execute the Python code. For the first scan, I'm getting for 0 degree 1 2 3 0.0 mm towards 0 degree. So since it is not properly visible over here in SE2L designer, we'll just see for 45th degree it is crossing 1 meter, not more than not away from more away from 1 meter. So that's why the reading is nearly 1162.0 mm. So values will be varying because the scanning values varies. There is some tolerance which is available because we if you are because in the live environment, reading of analog is not fixed, it is of little movable, so we cannot get a fixed value over here. Then can you see for 135 degree, this is for 1 meter, it is quite less than 0.5 meters, so that's why we are getting a reading of 415 mm. Okay, so just correlate with the 225 degrees as well, it's nearly 500 mm, that is 519 to be specific. So let us move on to the practical part. I'm not having the Linux system, it's a Windows based, so I have installed the virtual OS of Linux. So I'll be opening the virtual part of it. If you are having a Linux system, definitely you can go with it. So I have done the ROS scan over here on the desktop. I saved the ROS scan Python code on the desktop, so I'll be opening the terminal from here itself. So as I said to you initially, we have to run the ROS core. So core has been established, that means master node has been created. Then ROS run, I have already done the few of the executions. So ROS run urg node to run the SE2L's node. So it will stream the data. Okay. Then once the streaming is started with SE2L, that means ROS is communicating with SE2L. If it is not communicating, then there might be some problem with the communication. You can try and ping the SE2L from the Linux system, or you can check the ROS connectivity whether the core has been opened or not, right? Then after that, after doing the core and the streaming of data with the SE2L, now is the time we need to visualize. So this is just for monitoring purposes only. So our ROS run rviz is the command. Once we execute it, a separate file will be opened. So in that, as I said to you, okay, it is opening, still it is opening, I think. Okay, done. Then click on add to add the laser scan. Here the topic name is scan and the frame is laser. So hope you can see that once we have done that, we are able to see the actual SE2L's data. So I'll do one thing, I'll try and move some object nearby. So can you see, this is SE2L over here. I'm trying to move some material near to the SE2L. So I'm taking it away, I'm bringing it near to the SE2L. So I'm bringing it back. Fine. So this is for visualization only. The actual crux is to check the actual data, to take the data and to utilize the data in the later on phases. So for that, I'll not be covering the topics which I have shown to you in this slide. Straight away I'll jump to the eco part. So ROS topic eco, that means to get the data, scan is the topic name, and hyphen n1. So once I do this, it actually pulls the data. So this is how this is all the values which we are showing is the intensities over here. And if you go a little further up, these are all the distance values, distance measurement values. So here is the header and the angle minimum maximum which I've shown you here, right? So to check that, we need to execute ROS MSG show sensor data, the laser scan. So the formats, the data type formats, you can check with the help of this specific command, but actual data will be done with the help of, will be seen with the help of ROS topic echo scan. So this is just for checking purposes only, testing purposes. To get the actual data, I already have written the Python code. So Python 3 roscan.py. So roscan.py is a Python code which I have written. I kept it on the desktop. So you can see I am getting the data. I have clicked Control C to end the receiving of data. So here is the actual data. Value 0 degrees. At 0 degrees it is 123. Okay, now how to check? Maybe I can open SE2L, connect. We can try and monitor. Right, so here you can see that at 0 degrees it is going very far away. It is more than 1 meter, right? So this is 1 meter. You can see here 1 meter. So it is little less, it is little more than 1 meter. So we can see the data over here. So for 0 degrees it is around 123.0 mm. Then for 45 degrees it is little more than 1 meter. That is 1162.0. Then 135 is over here. So it is it's less than 1 meter. So 1 meter is this one. Maybe in terms of centimeters, I mean it's quite nearer to 41.5 centimeters, right? So this is how we can get the data. So once we get the data in the with the help of Python code, I think this data might be useful. So here I have been printing the values in the Python code. So if there is any remote the other connectivities, then definitely we can try and integrate this data. Instead of print, we can integrate the MSG range directly to the device which we are trying to link up with, right? So thank you for the session, and we will try and come up with more videos in the other video solutions. Thank you.